Hello students, welcome to the concept operations on independent variable. And the concept of signals and systems, x of t is representing the signal and we know this is the dependent variable and this is the independent variable. Okay. In the last video, I explained about operations on dependent variable. Now in this video, I'll explain about operations on independent variable. The main operations include, okay, here the operations are on the time. So the main operations include time shifting, the second, time scaling, and the third, time reversal. Okay, now let us start the first one, time shifting. We shifted in time by replacing t with the t minus t naught. Okay, you have x of t, the signal x of t. If this t gets replaced with the t minus t naught, that is called the operation time shifting. So here are two cases if t greater than 0. Okay, so if the shift is greater than 0, it's like if it is like t minus 2. Okay, then the signal is shifted to the right and the time shift results in delay of the signal by t naught units of time. I'll explain. If t naught less than 0, the signal is shifted to the left and the time shift results in advance of the signal by t naught units of time. I'll explain through a graph. Take this as your signal. So on x-axis it is t and on y-axis it is x of t and this is t is equal to 0. Now if I want x of t minus t naught and if t naught is positive, the signal is like this. What is the concept here? If t naught is greater than 0, the signal is shifted to the right. What is the right here? This side is the right side. So let it be the t naught. Your signal is like this. See, the center of the signal is at 0 here in x of t, but here the signal is like this. This is the signal. Okay, so here the center is at t naught. Now I'll draw x of t minus t naught case, but here t naught is negative. So if t naught is negative, it becomes t plus t naught. So now I'll draw the signal. Okay. So now t plus t naught. So you just make t plus t naught is equal to 0. Your t becomes minus t naught. Here also you just make t minus t naught is equal to 0. You will get t is equal to t naught at which the signal center will occur. So this is your minus t naught. See the signal, the center is at minus t naught. Okay. The general shift is represented with the x of t minus t naught. You must remember. But if t naught is positive, it becomes x of t minus t naught. If t naught is negative, it becomes x of t plus t naught. Okay. So if t naught is positive, it becomes x of t minus t naught and the signal is shifted towards the right. And if t naught is less, means negative, it is x of t plus t naught which gets shifted to the left. Okay. So now this is about the time shifting. We'll do one problem. We'll plot some waveforms. First problem, we'll plot x of t is equal to u of t minus 4. You know u of t, but here is u of t minus 4. Make t minus 4 is equal to 0, means your t is at 4. So the signal is like this. And you know u of t is like this. Okay, this is 0 and this is t. This is u of t. But this is u of t minus 4, which is a shifted stop signal. So this is 4. This is u of t minus 4. So the signal starts from 4. This is u of t minus 4. Okay. And now I'll plot x of t is equal to u of t plus 3. Means the signal is shifted to the left. So take at t minus 3. So this is minus 3. So the signal is like this. This is u of t plus 3. X of t is equal to t minus 5. If x of t is equal to t as a ramp signal, anyway I'll explain different continuous time, elementary continuous time signals in the next videos. So this is the ramp signal. Okay, it starts from 0. But it is the delayed ramp and the delay is 5 here. So the ramp will be like this. This is the ramp. Okay. And if suppose I want x of t is equal to t plus 2. So here that is the time advance. So minus 2. This is the ramp. Okay. It may be the time advance and time shift. The signal must move towards the positive side because here t is positive. Remember. Now we'll move to the second operation, time scaling. The time scale signal is represented by x of at, where a is scaling factor. Okay. If a greater than 1, the scaling results compression. If a is between 0 and 1, scaling results expansion. Compression of the signal, expansion of the signal in time wise, you must remember. Okay. So as this is compression, this is the speed up the signal and this slow down the signal. Okay. I'll explain by taking. So take this signal. X of t is a pulse signal, let it be 4 and the amplitude is 1. If I want x of 2t, okay, here the scaling factor is 2. What you have to do is, listen carefully, simply you just make these 2 points 0 and 4 t axis మీద ఏ points అయితే ఉన్నాయో ఆ points మొత్తాన్ని ఈ a factor 2 తో divide చేయాలి. 0 by 2 and 4 by 2. So we got 0 and 2. So just you keep here 0. And as this is 4, this becomes 2. So but the amplitude is 1. So the pulse signal is like this. This is the pulse signal. Okay. See the signal? It gets compressed. Okay. So lateral ga means horizontal ga size తగ్గిపోయింది. That is called compression. అంటే సిగ్నల్ చాలా ఫాస్ట్ గా అయిపోయింది, అందుకనే దీన్ని స్పీడ్ అప్ ప్రాసెస్ అన్నారు. సపోజ్ అదే నేను x of t by 2 తీసుకుంటే ఏమై ఉండేదో చూడండి. సేమ్ ఇక్కడ ఎలా అయితే 0 by 4 4 by 2 చేశారో అక్కడ ఏం చేయాలి, 0 by ఇక్కడ t by 2 అంటే 1 by 2 కదా, 0 by 1 by 2 and 4 by 1 by 2 చేసుకోవాలి. t కి ఫ్యాక్టర్ 1 by 2 కదా ఇక్కడ. సో we'll get 0 and 8. సో 0 తీసుకోండి and 8 ఇది. Here the amplitude is not changing, so the amplitude is 1 here. See the pulse, this is the pulse. So ఏమైపోయింది ఇక్కడ, expand అయిపోయింది కదా, అంటే time axis along the horizontally it gets expanded, means the signal కూడా చాలా స్లోగా గానీ ఆ సిగ్నల్ షేప్ ని కంప్లీట్ చేసింది. That is the reason it is called the slow down process. Okay. So now again I'll do one problem. Suppose if x of t is given like this. Triangular signal. Then plot x of 2t and x of t by 2. సో ఏం చేయాలి x of 2t అంటే ఇక్కడ ఉన్న ఈ 3 పాయింట్స్ కి డివైడెడ్ బై 2 చేసుకోవాలి. ఓకే, సో minus 1 by 2, 0 and 1 by 2. So simply this is minus 1 by 2, this is 0 and this is plus 1 by 2. And here the given amplitude is 1. So you'll get 1 here. So this is the signal. Okay, compare this with the original signal, it gets compressed. Okay, same way. To draw x of t by 2, you have to make 1 by 1 by 2, 0 by 1 by 2, 1 by 1 by 2. So it becomes minus 2, 0 and plus 2. Okay, so let be 0. So as this is 1, the double is minus 2. So let be 2. Amplitude is 1 again. See the signal. Okay, so slow down signal. That's about time scaling. Now we'll move to the third one, time reversal. This operation is denoted by x of minus t. So this operation results folding of the signal or a reflection of the signal. I'll explain clearly. Or I can say time reversal about origin t equal to 0. I'll explain by a graph. Suppose if the graph is like this, if this is x of t, then x of minus t ఎలా డ్రా చేయాలి అంటే జాగ్రత్తగా వినండి. ఈ పాజిటివ్ t లో ఏమేమి పాయింట్స్ ఉన్నాయో అవి నెగటివ్ అవుతాయి. ఓకే, అండ్ నెగటివ్ వైపు ఉన్నవి పాజిటివ్ అయిపోతాయి. అంటే సింపుల్ గా మీరు ఏం చేస్తున్నారు, అబౌట్ ద ఆరిజిన్ ఓకే సిగ్నల్ ని మీరు ఫోల్డ్ చేస్తున్నారు. ఫోల్డ్ అంటే పాజిటివ్ ది నెగటివ్ వైపు మూవ్ చేస్తారు, నెగటివ్ ది పాజిటివ్ వైపు మూవ్ చేస్తారు. అంతేగాని సిగ్నల్ మొత్తాన్ని తీసుకుపోయి అటువైపు తిప్పాల్సిన పని లేదు. పాజిటివ్ ది నెగటివ్ కి, నెగటివ్ ది పాజిటివ్ కి. సో ఒకసారి చూడండి, 1, 2 పాజిటివ్ లో ఉన్నాయి కాబట్టి ఇక్కడ నేను -1 అండ్ -2 ఇండికేట్ చేస్తున్నాను. అండ్ తర్వాత ఇక్కడ -1 ఉంది కాబట్టి ఐ ఇండికేట్ +1. సిగ్నల్ ఎట్లుందో చూడండి, -1 నుండి 2 కి వెళ్ళింది కదా. ఇప్పుడు ఎక్కడ నుండి 2 కి వెళ్ళాలి, 1 నుండి 2 కి వెళ్ళాలి. యాంప్లిట్యూడ్స్ ఇండికేట్ చేస్తున్నాను 1 నుండి 2 కి. See the signal. So if you observe, just the signal gets folded, means the reflection or we got reflection. Okay, positive side move to the negative and negative is moved to the positive. Okay, yes, this is about time reversal. I'll take some examples. Plot the following. If x of t equal to t, plot x of minus t. So you know x of t is equal to t. It is the ramp function. It is like this. This is x of t. So now to plot it, simply you must fold it. X of minus t. So simply this is x of minus t. If x of t equal to u of t, plot x of minus t. What is u of t? Unit step function. The unit step function is like this. It starts at 0. And if you plot x of minus t, yes, it is simply the reversal. The signal will be like this. You know the amplitude is 1. This is 1. This is 0. This is minus t and this is plus t. Okay, this is all minus t. So this is about time reversal. Simply you have to reverse the signal. Positive ni negative cheyali, negative ni positive వైపుకి move చేసుకొని డ్రా చేసుకోవాలి. Okay. So in the next class, we'll solve some problems by mixing all these three operations. Okay. Thank you very much.